Let's just jump right into today's topic, which will begin with trigonometric equations. All right, let's take a look. All right, so what we have, first problem we're going to work on is this problem where you have cosine theta plus 1 is secant theta. Trigonometric equations. By that we mean equations with these trigonometric functions within them. All right, so let's write that again, just in case you can't really see it very well. Cosine theta plus 1 is equal to secant theta. First step here is to be able to see that you have two different trig functions. And because of that, what you can do is you can use what we call an identity, where you'd have to understand that secant theta can be rewritten. Secant theta can be rewritten. The secant theta is a reciprocal of cosine theta, so that can be rewritten as 1 over cosine theta. Now, you have a fraction within this equation. One of the things that you learned in Algebra 2 is that you can rewrite this equation by multiplying by the least common denominator. In that case, it's cosine theta. And you distribute that cosine theta to be cosine squared theta plus cosine theta all right, is equal to 1. All right. So now what you're going to do is see that this is a quadratic equation. You subtract the 1 over, you get cosine squared theta plus cosine theta minus 1 is 0. All right. So now you're going to solve that. All right. All right. So what you should do now is this does not look factorable. All right. This does not look factorable. So this is a little bit more demanding problem. Let's see what we end up with here. If you were to find the discriminant of this, you'd get 1 squared minus 4 times 1 times negative 1. All right. And you end up with 1 plus 4, which is 5. All right. So you're going to have to use a quadratic formula for this because it's not factorable. I think we're going to need a little bit more space up here. So let's use a quadratic formula on this. All right. So what we end up with is, let's make x equal to cosine theta. So what we end up with there is x squared plus x minus 1 is 0. So we have cosine squared, or x squared, plus cosine x, but we call x cosine, so that's plus x, and then we got minus 1 is 0. Let's solve that. We've already found the discriminant, which was 5. So the way we're going to solve this is we end up with negative b, or negative 1, plus or minus the square root of the discriminant, which was 5, all over 2 times a, or 2 times 1. So you end up with negative 1 plus or minus the square root of 5. The square root of 5 is, let's see here, the square root of 5 is 2.236. So 2.236 all over 2. And then what you end up with is 2 answers. The first answer is, that's minus 1. And then let's divide by 2. You end up with 0.618. 0.618. The second answer. The second answer is negative 1 minus, make it so you can see it, negative 1 minus 2.236, and then that's divided by 2. So we end up with negative 1.618. So now what you have is you have x, and don't forget that we said that x was cosine theta. So we have cosine theta is equal to 0.618, and then we have cosine theta, is equal to negative 1.618. And then what you discover here is that the cosine of theta is never less than negative 1. The cosine theta is never greater than 1. So this is not going to yield an answer. That's not going to yield an answer. So what we want to do is, where's cosine positive? Cosine is positive in this quadrant and in the first quadrant. You put this in your calculator. Put this in your calculator. And then you have the arc cosine. All right, we have a call, and we'll be with that call in 1 second. 0.618. The mode is let's put this in the degree mode here. Let's put that in the degree mode. And let's quit out of that. So we have arc cosine of 0.618. We get 51.83 degrees. Put a 51.8 here. Put a 51.83 here. And it turns out that our answers would be theta is equal to 51.8 degrees. And then the other answer would be 360 minus 51.8, and then that would be 308.2 degrees. 308.2. I don't know if you can read that. 308.2 and 51.8 degrees. We had a problem like so. I'm hoping you can see that. 3 cosine 2 theta plus 8 sine theta plus 5 is 0. All right, so one of the things that we talked about last time was, here you have cosine 2 theta. Here you have cosine 2 theta, and you have a sine theta. You desire that these trig expressions be the same and not different. And fortunately, we have something called identities. We have identities. One identity that we've used in the last show was tangent theta is equal to sine theta over cosine theta. We used that in the last show. Well, other identities that are available to us, cosine 2 theta is equal to 3 different things. Cosine 2 theta can be written in terms of cosine and sine squared. Cosine 2 theta can be written in terms of sine, and cosine 2 theta can be written in terms of cosine. Well, if you look at your original problem here, your original problem has sine in it. You want to change this over to something that has sine in it so you can solve this problem. So hopefully it makes sense to you that we would replace our cosine 2 theta with that, with the 1 minus 2 sine squared theta. Let's do that. So we have 3 times 1 minus 2 sine squared theta. So we replaced the cosine 2 theta with 1 minus 2 sine squared theta. Plus 8 sine theta, I'm just bringing that down, plus 5 is 0. All right. So now let's distribute that 3. We get 3 minus 6 sine squared theta plus 8 sine theta plus 5 is 0. All right, so let's keep going. Let's keep going. I think what's going to be helpful for us, at least for me, is I prefer positive squared terms. So I'm going to combine these terms, and I'm going to move everything to the right in one step. So I'm going to add the 6 sine squared theta to the right. I get positive 6 sine squared theta. I'm going to subtract the 8 sine theta on both sides. So that would be minus sine theta. And if you bring these two terms together, you get 8. But I'm going to subtract that over, so we get minus 8 is 0. That's not clear, you call in. That's not clear, you call in. So let's factor out a 2. If you factor out a 2, you end up with 3 sine squared theta minus 4 sine theta minus 4 is 0. All right. So let's try to factor this out. Let's see if it's factorable first. Let's see if that's factorable. We end up with b squared, that's 16, minus 4 times 3 times negative 4. All right, let's see if that's factorable. We end up with 16 plus 48, and you get, that's going to be 64. So that, the fact that this is a perfect root, that tells you this is factorable. So let's go on and factor it. Let's go on and factor it. We end up with 3 sine theta, and you end up with, let's see what we can do here. Minus 2 plus 2, that works out. If you check that, you get minus 6 plus 2, minus 6 sine theta plus 2 sine theta gives you the negative 4 sine theta. So this works out. So now you set both of them equal to 0. You set this equal to 0. Sine theta minus 2, you set that equal to 0. You're going to get sine theta is 2. And you notice the sine curve never goes above 1, and it never goes below negative 1. So this will not yield an answer. Sine of theta will never be 2. This will not yield an answer. But over here, you get 3 sine theta plus 2 is 0. So you get 3 sine theta is a negative 2. And you get sine theta is a negative 2/3. And now you're about to get your answer now. Okay, so the way you're going to get your answer is you ask yourself, where is sine negative? We were just on the phone with a young lady where we said that all students take calculus. Everything's positive here. Sine is positive there. Well, sine is negative here and here. So now what you're going to do is you're going to put in the calculator the arc sine of 2/3. Let's put that in the calculator. So the arc sine of 2 divided by 3, and you end up with 41.81. So your reference angle is 41.81. You put 41.81 here. So your answers are going to be, this is 180 degrees here. From here to here is 180 degrees, but I want that angle. So you take 180 plus 41.8. All right, so you add to that 180, and you end up with 221.81. So one answer is 221.81. All right, that's this angle right there. And the other angle is 360 minus that. We want this angle right here. The best way to get it is to go back past the angle and then subtract it. All right, so we have 360 minus the 41.81, and you get 318.19. The other answer is 318 degrees, 0.19. Final answers.